Now we're ready to review how we reduce or simplify rational expressions. And you'll remember this. You did this type of reduction back in Algebra 1 and in Algebra 2. And remember, if we have a rational expression, that means we're going to have some type of a polynomial over a polynomial. That can look like this. And if we have a fraction that is simplified, that means that our numerator and denominator will have no common factors. Now, when we reduce fractions as in numbers, say I gave you something like 12/36 times, let's say I took 4/3. And if I wanted to reduce this down, we know we're multiplying fractions and we could multiply straight across, but we want to think about factoring. And I'm going to do this kind of in a little bit funny form, but 12 breaks down to 4 times 3. I could also break it down to 2 times 2 times 3. And in the denominator, I can break down 36 into 4 times 9 or 4 times 3 times 3. In fact, let me change that 9 to 3 times 3. Now, I haven't factored completely. Here, this 3 comes from here. The product of these numbers is 36. 12 is these two values, and then I have the 4. And if we multiply again, we multiply straight across. But we want to simplify this. Now remember, any type of factor that is, if we have a product of numbers, any type of factor that's in the numerator can be reduced with that similar factor in the denominator. That factor can reduce, that factor can reduce. And then I would have left with 1 times 1 times 4, or 4 in the numerator, and 1 times 1 times 3 times 3, or 9 in the denominator. And if we can do that type of simplification with numbers, we can basically do that type of simplification with rational expressions. And the idea is we want to factor and then reduce. And that's what I have. We will factor, then we'll reduce. So let me move that paper out of the way, and let's go to this first example. And I have it all worked out, so it will save us a little bit of time. But I have a multiplication question. I can't start hacking or reducing right away. I have to factor. So, zoom in a little bit here. I went through the process of breaking down. I knew that 3x times x had to give me the 3x squared. I knew that 2 times 1 had to give me the 2. I knew we need one of them to be negative. I need to get the right middle term of 5x. So I broke down this trinomial as the numerator. And the denominator has degree 1, so I won't have any factorization to do with that. Now the second fraction, once again, I have to break down. I see good old difference of squares here, x plus 5, x minus 5. And then in the denominator, I have that trinomial. I know there's no greatest common factor to pull out. And 3x squared breaks down to 3x times x. And I know I need a 2 and a 1. Got to put it in the right spot. Product of the two has to be positive 2, but I have to get a negative middle term. So I know both my factors will have a negative sign. And negative 6x and negative 1x do add up to the negative 7x. So I have all of this factored out, and now I'm ready to reduce. And when I reduce, anything that is alike top to bottom, this factor and this factor reduce out, and there are 1s there once we reduce them. This factor reduces this factor, and again, I replace those with 1s, or I reduce them down to 1s. They don't become 0s, they become 1s. And then in the end, this x plus 2 factor is not the same as that x minus 2 factor, so I'm going to have that x plus 2 factor left. I also have this x plus 5 factor left, and then I have an x minus 2 factor in the end. So that's the simplified version. Now I could go further and write that as x squared plus 7x plus 10 all over x minus 2. However, I will let you leave the answer in a factored form in the numerator and in the denominator if there happen to be more than one factor in that denominator. And I see we're getting kind of a glare there on the screen. But now, next step is we have to look at what are the restrictions on our variable. This original expression has lots of infinitely many values that I can substitute in. However, there are some that I can't. Anything that would cause the original denominator to turn to 0, that would be something that I can't plug in. So I can see right here, although this x minus 5 reduced out once I simplified, I still am finding restrictions on the original problem. So I can't plug in 5. I also look at the factored version of this denominator. Now, once again, this 3x minus 1 factor did reduce down. However, I have to give the restriction for it because it was in the original problem. So when does 3x minus 1 equal 0? Add 1 to both sides and divide by 3. I find out that occurs at 1/3. And I also have a restriction of 2. So these three values are the only three that I can't plug into the expression. And if I plug numbers into this big product of two fractions or into this simplified version or this factored version of that value, I'll get the same answer. So these are equivalent, and this is the restriction on my variable. Now I'll write this second one over and go from scratch and write with a little bit darker pencil than I had on the other. All right, so again, I need to simplify. I can't do any reduction here due to the fact that I have subtraction. If I have a product of a whole bunch of terms, then I can do reduction. So I have the difference of squares in that numerator, a plus 2, a minus 2. In the denominator, oh, good, I see another difference of squares. We love that when that happens. I don't even have to think when I'm factoring. Now I have an a plus 1. Good. Have a first power, first degree on that, so I don't have to worry about pulling anything out. And then be careful here. Always look for the greatest common factor. Now, what I may want to do is I have to state the restrictions on the variable. Before I start reducing anything down, I'm actually going to give my restrictions. I know I can't plug in -1. I know I can't plug in 1. An a value of 0 will also be a problem, and an a value of -2. So those are my restrictions. I have 4 numbers that after I do my reduction that I'm not going to be able to plug in place of a. And now I'll start to reduce. This a plus 2 reduces that a plus 2. That a plus 1 reduces that a plus 1. And it looks like that's all I can reduce down. So I have a minus 2 left in the top. And in the denominator, I have a and a minus 1. Now, if you want to distribute that bottom out, you may. You may call it a minus 2 over a squared minus a. However, this answer is sufficient for me. So if you plug numbers, oops, I see that's off the screen. If you plug numbers into the original expression for a or into this expression or this expression, they will yield the same answers. Now, these are the only numbers that you're not allowed to plug in. Now, let's review division. And when we have division of fractions, we know that if I take a fraction divided by a fraction, we change it to a over b times the reciprocal. And now, interestingly enough, we're going to have more restrictions on our variables here. We know that b could not equal 0 in the original fraction because this could not have division by 0, nor could d. But also look, this c ends up becoming one of our denominators, so c could not equal 0 either. So we can't have division by have the denominator be 0, and this numerator becomes a denominator. So we actually have 3 restrictions, which is going to cause us to have more things to look at when we're reducing a fraction down. So now we have a division problem. Now I have it in factored form, almost all in factored form for you. And so we know that we will have to take this first fraction times, and we'll have to reciprocate the second fraction. Now, before I do that, well, let me write the second one over. Let me reciprocate, and then I'm going to do something right in this step too. So I'm going to have this first fraction, which I'll write down my denominator. I'm going to do something to that numerator. I'm already looking ahead. And that's going to be times, and I need to reciprocate. There we go. Now, I know this is a 3 minus y here, but I see a y minus 3. And so I can see that this factor is not exactly the same, but it's really close. So what I'm going to do is I'm going to factor -1 out of this and see if I can get these two to be basically the same. And notice A negative 1 times negative 3 will give me positive 3, and a negative 1 times positive y will give me negative y. Now this factor could also be written as, because of the commutative property, y plus negative 3 or y minus 3. So now I will be able to reduce these factors down. However, before I do that, I'm going to get these restrictions before I start doing a more reduction, and then I can't see what I've canceled out. So let's see. In the original fraction, I can see 1/2 would be the number that makes that factor turn to 0. I can see negative 5 is bad. Now, I'm going to go back up here. 1/2 in the original fraction, I already have a restriction for that. That could not be 0, and I also cannot have x equals 7. Now I reciprocated, and now I have to watch out for y being 3. Well, that's y now rather than x, so we'll have to go down here and say that y cannot equal 3. So those are my restrictions on what I can substitute in. I happen to have two different variables here, and I have more restrictions on what I can plug in for x than y. But basically, any numbers other than these I can substitute in. Now let's figure out what the simplified expression is. This 2x minus 1 reduces that 2x minus 1. That y minus 3 and that y minus 3 reduce down. And that looks like all I'm going to have. So we have a negative 1 here. We have an x minus 7 left. In the denominator, I have that x plus 5 and a 6. Now, once again, if you want to distribute that back through, this answer is sufficient. If you want to simplify that and distribute it through and say negative x plus 7 over 6x plus 30, you are more than welcome to do that, but this answer is a sufficient answer. As long as it's reduced down, you'd be good to go. Now, let's flip to the back and have one more expression here to look at. And number 4. You may want to actually turn off the video and do it on your own and then go back and double check. So remember, we need to do some factoring. And I need the product to be 15. And it looks like 5 times 3 will do it. One of them has to be negative. And I need a positive middle term, so let's do it that way. Yay, difference of squares. Now I have to change it to times. And I do have a common factor. This will become my new numerator. 3 times a minus 4. Oops, broke a little lead. And then I have that a plus 1, which will go to the bottom. Now I'm ready to start my reduction, or I'm going to get those restrictions again. So once I reduce, sometimes I can't see what I've canceled out. Okay, original denominator, I can't have a be negative 4. I can't have a be 4. In the original denominator here, a couldn't be 4. Well, I already took care of that. And then when I had to reciprocate, oops, I can't use a of negative 1. So those are my restrictions. And now let's do the reduction. So let's see. That one reduces. Well, this isn't going to reduce too much, is it? All right, so looks like those are the only factors that are going to reduce. So what do I have left? I have a 3 on top. I have an a plus 5, an a minus 3, and down in the bottom I have 2 factors. You can put them in either order you want. Now once again, that answer is sufficient with these restrictions. If you want to multiply this out, you may, but remember, if you did multiply this out, you would not distribute 3 through all these. I normally multiply the 2 binomials together and then distribute the 3 at the end, but you can just as well distribute the 3 through here, call it 3a plus 15, and then multiply by a minus 3. But this is fine. You can leave it right in that form for the problems. All right, and now you're ready for some practice.